Okay, so the first technique is known as amplitude shift keying or ASK. So basically, ASK is implemented by changing the amplitude characteristics of an analog signal. So for example, if we have a digital bits of zeros or one, if we represent zero by an fixed amplitude and one by another amplitude, then based on these changes in the amplitude, the receiver can uniquely identify either the signal is representing a 0 or 1. Okay, so here we can see an example. Here, as we can see, a 0 bit, sorry, a 1 bit is represented by a fixed amplitude, and here basically a 0 bit is represented by no amplitude. Okay, so if the amplitude is let's say this is 5, so if the amplitude is 5, so the receiver can uniquely identify it is as 1, and if the amplitude is 0, then the receiver can identify it is as 0. Okay, and here is part of the signal is known as signal element. So basically this is a signal element, this is a signal element, this is a signal element, and so on. Okay, so here as we are representing 1 bit and 0 and 1, so this is known as binary shift key. Okay, so and as here we are using either positives, either an amplitude or zero amplitude, it is also known as on off keying or over keying. Okay, so here is another representation of this binary ASK. So this is our original digital signal or digital bits, and this is our carrier signal. So as we can see in this carrier signal, all the signal elements are actually identical or simple or same. Okay, and based on these digital bits, we have basically changed these carrier signals. So where the bit is one, we did not change this, or we did kept it as it is, and if the signal it is 0, we made it we or change the amplitude to 0. So basically we have changed this carrier signal to this modulated signal, and this modulated signal will be sent from the sender to the receiver, and the receiver will receive this modulated signal and it will compare it with this carrier signal, and as it will see changes here and here, so it can uniquely identify that these bits are 1 but these bits are zeros. Okay, so this is our binary amplitude shift key. So in binary amplitude shift key, we are basically manipulating or sending one bit for each data element, but we can actually send multiple bits in each signal elements. Okay, so for this we use multi-level amplitude shift key. Here is an example of a multi-level amplitude shift key. Here for 0 0 we are using this amplitude, for 0 1 this amplitude, for 1 0 this amplitude, and for 1 1 this amplitude. Okay, so we will basically manipulate the carrier signal into one of these amplitudes based on the data, and the receiver will receive this manipulated signal and it will compare it to the carrier signal, and if it see the changes or see the amplitude like this one, so it will represent it by 0 1. If it see, let's say, signal element like this one, so it will convert it to 1 1. Okay, so based on this idea, we can actually send multiple bits by one data element. That is why it is known as multi-level ASK or multi-level amplitude shift key.